Welcome to Tenor Tech, where I solve the problems you didn't even know you had.
You start by securing compute, credentials, and a reproducible environment. This matters because reproducibility saves days. Once done, provision GPUs or TPUs and install CUDA drivers. Make sure Docker images match your runtime. Next, clone the model repo and enable Git LFS for weights. Create a virtualenv and pip install requirements. Then, obtain any API keys and service quotas you need so training and evaluation won't be interrupted. Finally, prepare a small validation dataset to sanity check the pipeline immediately. You will now assemble the core training loop and data pipeline because this is where the model learns. Start by tokenizing and sharding your dataset. Validate token distribution and remove duplicates. Configure architecture hyperparameters and choose an optimizer. Use warm-up steps and a conservative LR to avoid divergence. Set up mixed precision and gradient accumulation for memory savings and enable regular checkpointing with timestamps. Once running, monitor loss curves and GPU utilization. Adjust batch size or LR if memory or instability appears. You finish by validating and preparing the model for production. Evaluation explains how good it is and why. Run automated metrics like perplexity and targeted prompts to test behavior, include safety filters and human review. Convert checkpoints to an optimized runtime format, apply quantization if needed, and build a container for inference. Deploy with auto-scaling, monitoring, and a rollback plan so incidents don't escalate. If outputs are toxic or collapse, reduce LR, reload a recent checkpoint, and rerun training with stricter data filtering.
Thanks for watching. Subscribe to keep your life in tune.